Hello and welcome to a new session of Hitchhiker's Guide to the Glamorous World. And today I'm joined here by Andy Burnett. Hi, Andy.
Hello.
Hi. So in these sessions, we are guiding newcomers to Glamorous Toolkit and multiple development around. But before we go into those kinds of details, let's maybe hear from you. So maybe describe yourself and then we go into, what brought you to Glamorous Toolkit.
So I'm CEO of a strange consulting firm. We're known as KI. It's no innovation. Although we own both domains, so you either want to know about it or you don't have it, or you're trying to stamp it out. But our interest for the last 20 odd years has been the intersection of the psychology of creativity, and particularly the focus around creative problem solving and scientific research. So it's sort of an area that my colleagues and I drifted into by accident. But what we realized, we were approached many years ago by one of the academic funding agencies, and they said, we would like to encourage more interdisciplinary and novel research projects to emerge. And they said there is a class of problems, and climate change is a good example, where it's not just that we don't necessarily at the time know how to solve it. We don't even agree on a definition of what the problem is.
Yeah.
And they said the problem that they experienced as a funding agency was that it was quite hard to encourage researchers from a wide range of disciplines to come together and talk with each other, not least of which is because often they didn't share a language with which to actually communicate about the problem. And this was of interest to us because for us, our background was the psychology of deliberate creativity. Now, up until then, this has often been thought of as sort of advertising and how do you come up with new names for things, and that's a valid use of it. But as we began to look into this, we realized that a lot of the basic principles around creative problem solving actually focused on being able to have conversations with people who were sharing very different idea spaces. And so where we had been teaching students, this is how to effectively take long jump thoughts, we suddenly found that a lot of these approaches were helpful in developing interdisciplinary research projects. And so that was where we started, and we now do this all around the world, and it's fascinating. But from a very early point in time, we had this thought that actually we could probably do this better augmented with technology, or possibly fully remotely. And so we've been experimenting for a long time with even tools way back in the day with things like Lotus Notes and other systems for being able to try and understand how do we do this. And what really excited me when I saw one of your videos about Glamorous Toolkit was the idea of being able to create cheap, on-the-fly tools to model and explore problems and questions. And the reason I found that so exciting was, over all the years of doing this, our sort of general conclusion was, if you give a sort of smart and motivated group of researchers a question, they will come up with ideas. They're good at that. The hard part is actually getting them to ask better questions. And that was why being able to have a toolkit where you could, potentially anyone could sort of on the fly explore a problem space and reframe the questions seemed really exciting. And it sort of drifts into knowledge management, but that was really what I thought, okay, I know you're using this to explore and understand code, but I've got a different idea around this.
Oh boy, this is so exciting. Um, oh yeah. So okay, so that's a new perspective to look that we hear of, but we let's put it differently. So one of the things, so for example, you mentioned knowledge management. Like if you think about knowledge management as a space, like a technology space, it's certainly considered to be completely distinct from programming, for example.
Mhm.
Um, and that's fascinating. It's a fascinating perspective to us because what is code at the end of the day? Code is just executable knowledge.
Right.
So any perspective on knowledge or on some form of external representation of our thoughts that does not include code today is utterly incomplete.
Right.
But it happens to be much harder to add execution to some form of representing knowledge than to add some form of representing knowledge to something that is already executable.
Right.
Um, and so what Glamorous Toolkit is, or it started as an environment for reasoning about systems, but the primary motivation there is really that today's society runs on software, and software becomes both law, so it describes the rules by which society works, and law enforcement. In other
Mhm.
words, you can't do what the system does not allow you to do.
Right.
And having both of those as black boxes that are unapproachable is rather scary, and it's something that we have to change. So that is, in fact, the primary or one of the core motivations for our work, and this is where we started from. But as we are learning more, it's quite fascinating to see people starting to make connections to nearby fields. And it only strengthens this idea that those fields are actually like this. The way we look at spaces is that's where the limitation comes from. It does not come
Right.
from anything, you know, inside or it doesn't come from an innate limitation. It comes from just our way of framing things, which are just maybe have historical reasons or historical practical reasons that are no longer needed or reasonable anymore. So this is this is certainly exciting. So the other thing I heard was that from your description, and that kind of sounded so interesting. So first of all, just having a company that enables others to ask better questions is already fascinating, and then having a company for so long as you're having doing that is even more fascinating. But it was quite interesting how you described how when you get two people with coming from different thinking spaces to focus on the same problem, how important it is for those people to share a common understanding of the problem,
Yeah.
not of the solution. And so where we see this one, and it's very, very apparent in, for example, in the software world, is where technical people want to describe to non-technical people something, and they need to come together to solve the problem, whatever the problem is, or to come up with something new. But like nobody knows what's inside the black box,
Right.
and nobody knows. We know, like pretty much nobody really knows how to translate it to people that are not inside there. They're not working inside that black box. And so that's where we started from. That's the kind of the core experience we're having. But I can definitely see how this could have more implications. But I would be very much interested to hear how you're seeing that space. So, like, uh, how do you see this a tool like that facilitating, given all your experiences before?
So I think the most interesting thing that we see in interdisciplinary research and generating new ideas from this is when you bring people who have very different training together around a problem, um, well, I'll give you an example. We were running some events on the opioid addiction crisis, which is just terrible. But
Yeah.
we had people who were on the pharmacological side. We had people who were looking at the psychological side, and they were talking about sort of drug psychology interaction and trying to think about how they frame the problem. And we also had a music professor who had been someone we'd recruited to come and join the event. And he was listening to this as well. And he said, it's really interesting that what I'm hearing from both the psychological and the pharmacological side is that the drugs affect the affective state. So they're affecting the emotional state. And he said, that's what I do. When I compose music, I influence your affective state. And he said, I think I know something about what the drugs might do, and that there might be other ways of achieving some of those states, and that I might even be able to offer some level of insight into what different states feel like, just a different perspective. And it was one of those moments where everyone stopped in their tracks and went, yeah, you're right, that's a completely different way of thinking about it. And the conversation changed. But what we find most exciting about it is it's not that the conversation moves from one person's view to a different person's view. It's that a new composite or possibly just completely different way of thinking about the problem emerges. And it is at this sort of intersection that you get really interesting insights. And so one of the things which just intrigues me about the toolkit is, could we give people ways of expressing their view of the world in a sort of computationally accessible way, so that I could look at your view of the world and say, okay, I agree with this and this, but my view looks like this. Now, where does it connect? And could we actually develop computationally supported models which let people express their ideas and questions in ways, I mean, how we do this, I don't know, but for the pharmacologist to be able to say, this is what drug-drug interaction looks like, here is this model, and for a psychologist or a contemporary dancer to look at that and go, okay, I understand that, and this is how my model might fit with this. And now let's talk about why our models don't connect and what would have to happen if they did. And I don't want it to be a sort of reductive, everything is software view, but we have very similar conversations when we're doing software design, or you're trying to bridge client requirements with technical possibilities. And being able to cheaply say, this is what my model looks like, now let's play with it, just seems a fascinating possibility.
So that's very exciting. So, okay, so there are like two things, right? So there's the far out idea of people expressing their ideas in executable forms so that we can start comparing. But, you know, if you think about that, that's basically what software is.
Right.
So how do people consume software? Because this is where the difference between typical development and what moldable development is. You know, how do people consume software? The way people consume software is through the interface that is presented to them. And this interface is usually what the end user will ever see. That's the only thing that we get to see. And, you know, if you think about like, what's the feedback loop, you know, like business, non-business, it usually is around some sort of a demo of the outside of the system. But but it's a very limiting perspective. So one of the things that we saw there is that once we started to understand that there is a way to express computation in a way that other humans can understand, we saw significant improvements in the effectiveness with which we can express these kinds of computations. So we saw like all these advances in UX, which on the one hand aren't advancements. On the other hand, I think they're many of them are actually missing the point. But let's come back to that a bit later. So, but it's definitely the case that today many more people consume much more computation that was consumable just a decade ago.
Yeah.
And slightly more knowledgeable, but on the other hand, we saw all sorts of interesting side effects. For example, just like the side effects of what happens with your data that nobody's aware. Why? It's not because the system is not there, but it's just because that's never what appears on the outside, right? It's the system does something with it, but it's never exposed to what the user will ever see. So but it's also the other thing that's interesting is how much what a kind of a power these kind of interfaces have on what people think about the computation with computation. So right, so you get to influence you can get to influence a large number of people about things that are not real, for example, right? There's like an extreme case, which unfortunately happens more often than we'd like to admit. So there's dramatic power in this translation. But the thing is that with software, everything in like any boundary in software is completely arbitrary. So whatever somebody says, oh, this is the interface, they just said, oh, okay, that's what a certain amount of, some population will be interested in this and this and this and these questions. So we will be giving them exactly these kinds of interfaces. And all of a sudden, if you have the sixth question, which is not there, then all of a sudden, boom, you're not going to be able to answer. You're totally, none of it will be translated to you. So, but the good news here is that if we can improve some answers, right, we can improve the answers to some questions, it follows that we should be able to improve the answers to all questions, if only we apply the same rigor to all other questions. And this is what basically, that's the realization that moldable development starts from, is that there is no single question about software that is less relevant than any other question. So, and if you start from there, and then it starts with the question that me, for example, as a developer of what I'm creating, I have about my own system. And then, of course, it goes to, some of my colleague who's a developer will have about the system. But then it goes further, and there's like, we as a group will have about the system. And then it goes further, like we, the business or the designers or the testers or the whoever, the regulators, anybody will have about systems. All of those are relevant questions. All of those should be answerable, but we can't answer them directly. There's this intermediary, because we can, in order to answer anything, that information has to reach our brain so that we can process it. But given that software doesn't have, and data in general doesn't have any shape, we have to give it some shape. And so there is this, that's what the power of this translation happens exactly in the shape that we give to whatever question we have. And this is not an off, it's not something that you do once occasionally when you have some sort of a larger problem. It happens to be useful for every single development problem. That's the interesting part that I think is relevant from all the work we've done is, so Glamorous Toolkit itself, we've developed it building like this. So one of the key, like before we started the conversation, we were talking about this remote work. Right. So the topic that appeared recently, or not appeared recently, but it got inflamed a bit recently on various Twitter threads. And so one of the things that we have noticed, and we didn't know that, we just observed it. We work as a remote team from the beginning. And we get to, in our case, even anybody can choose whatever they want to do, which sounds a little crazy, but at the same time, we seem to be able to produce a coherent result. And so the question there is how. And so we even took meetings out. We took the scheduling out. There's no pre-scheduled meeting, for example, that we rely on. But everything is completely asynchronous, and people meet if they agree to meet. But then I will just ask you, like, would you like to have a call? And then you'll say yes, and then boom, we'll have a call. But if no, you'll say no, and that's it. Now, what's interesting about this is basically we took pretty much all things we thought of as synchronization mechanisms. And because like at the end of the day, so what is a synchronization mechanism? It's multiple people with different backgrounds, with different experiences coming together so that they can start sharing a common understanding of the domain, of the problem, of the situation, so that they can move forward with some actions that will push the problem forward. And so if you remove all of these, and then if you look at any process, pretty much all of them will have some sort of synchronization mechanism in place. So for example, if you look at something like Kanban, right? There is somebody, it's not even the board that is a synchronization mechanism, it's the ordering of the backlog that is. So somebody has to order that backlog and say, this is a more important thing to focus on than the other one. But what if that doesn't exist either? So in our case, we don't have an ordered backlog. But still the question is, how do we come to some sort of an agreement as to what should happen? And how do we actually do it? And it turns out that the most interesting aspect of it, and again, like we did not know this up front, we just discovered it, or we observed it, is that if you start consistently building these views of all the problems that you have, we get to compress communication. And by compressing communication, I mean, if I want to get you interested in my problem, so that, pair with me, help me solve the problem, I need to make it enticing enough that you stop what you're doing, or
right.
And then you say, oh, let's take a look at this one. This sounds like an interesting thing, or sounds like something that I think I could help with. So what I will be focusing on a lot, like most of my energy when I solve a problem, is like you're saying, describing what the problem is in a view that makes the actual problem apparent. And so then I'm going to send you a picture and you'll say, wow. And sometimes, and it's more often than we'd like, that we just saw more and more of this. We saw that sometimes the solution comes back is another picture. We don't even get to talk a lot. We just say, here's a picture, and then here's another picture. So, I understand. So I can go and do that. And so there's a tremendous power, and I'm very sure, I'm very convinced that we are just scratching the surface of what's possible here. But
so that's really interesting, because if I understand you correctly, what you're saying is that by modeling the situation or visualizing the situation in the most useful way, everyone sees the what should we work on next becomes an emergent property of your visualization of the system.
Yeah.
Clearly, this is what we should work on next.
Yeah, and also it's also, yeah, exactly. So a lot of it comes like that. But then these pictures are not so much about, let's draw how it should look like. We do some of those, but those are like a tiny fraction of the picture. Most pictures are about, here's the current system, and I think we want it like this. Right? So it's, again, like it's not describing the future solution. It's just simply describing what the problem is.
Right.
Or a bug, for example. We would be focusing, we don't actually solve bugs. We just visualize them until, like, it's like when you're solving a bug, it's always like, it's ugly, it's not nice, and it's not pleasant. But then you can turn this experience completely upside down and say, I really want to make this bug or show this bug in a way that makes me, like, it's a pleasure to see the bug.
Right.
and once you do that, right? And then, so for example, our GitHub issues, most of them, like, they will have pictures of the problems. And this is the main mechanism with which we communicate. And so once you do this, and then of course you enrich the system so that it carries forward these kinds of views. Because once I deem it interesting, and once somebody else deems it interesting, well, then all of a sudden it's like, well, that view is the responsibility of the system to carry it forward. So that's like a principle. And then the system enriches itself with perspectives that were useful for some humans before. So when a new human come, or we come later to the system, it also happens that that this process, or a byproduct of the process, is that it has a tremendous amount of documents of views, not documents, but of views that were useful for some humans. And then when you start to be able to combine those views in a live environment, so that we see the environment not as a sick set of features, but as a language with which you combine basically views, create and combine these kinds of views and create narratives with it, then you get to, you pretty much you set yourself for creating millions of, in our case, millions of possible experiences. And this is just, it's like from a mental perspective, if we just compare it with the typical experience of just reasoning with and about systems, but just looking at some fixed set of views, usually some textual formats, is a dramatic improvement. So that's our experience, and so we get to, yeah.
So I want to pick up on that, because that seems like a really interesting point. And I'm reflecting on that in terms of our experience of watching research teams form and develop ideas. And one of the important things about that we've seen over the years is that a group will form around a problem, and there will be an idea that emerges that excites them for a while, and the conversation continues, but then for whatever reason, a different idea emerges, or their energy is shifted to a different way of thinking about the problem, and then they carry on and off they go on that way. And what's so interesting about it is that earlier idea, which may quite validly have been dropped, but it's almost like it gets forgotten. And on occasions, we will go back to groups and say, for a period of time, you were really excited about that. Are you clear on why you moved away from it? Because creative conversations are very dynamic, and it's just sometimes people forget about it. And what I'm interested about in what you're saying about creating views is you could think about this perhaps as a much more dynamic sort of notebook, in the sense of there was an idea, we built a view to help us think about it, and let's assume that we could map it perhaps as a timeline and be able to say, these were all the different ways we were thinking about this, and we've ended up at this. But often we will see situations where a solution emerges, people are happy with it, off they go, but there was still great potential in this earlier one. But often people don't remember the details. So to be able to rewind and almost re-inhabit that idea and play with it again would be so much better than drawing diagrams on flip charts, or even doing it sort of on electronic whiteboards, because you may have been able to capture more of your thinking about this.
So yeah, right. And we go as far as to say that any drawing about an existing system that happens manually is flawed. And again, like the main enemy where we started from. So there are multiple. So not all problems are the same. So there are problems, for example, like typical introductory courses or teaching materials. Very often they focus on programs, for example, that fit in one's brain as a whole. Mm-hmm. And those are so much different than problems that are that outgrow the brain with many
Yeah.
orders of magnitude. So the main enemy in the latter ones is that simply people have no idea what they are trying about the problem. They don't understand the problem in the first place. And the problem is not what the customer says or what the next feature is. The main problem is in the current system. So how does the current system look like so that you know what to change, how to change, when to change, and so on. And that is the by far the largest challenge. So today, I mean, we go so far as to say, when we go into companies, we ask people, "Do you have pictures about your system?" And they say yes. And then we said, "Okay, so can you bet your salary that the picture is real?"
Right.
It's a simple question, right? And then we haven't found yet people that can, because those pictures are drawn by hand. So when they are drawn by hand, they represent somebody's belief over what the system is. And it's very, very important when you're trying to, figure paths forward and make decisions, to distinguish between beliefs and reality. So that's the first order problem. This is not a sufficient solution. I'm just saying that that's the first order problem we're trying to solve. That before we can do any of the new patterns of how you're going to build the new world in a much better way, you first have to understand the current world. So for example, when we see too often, we see companies that say, "Wow, we really need to go there." Right? It's so important for the, strategically important for this company so that we are there in 2 years from now. Only then for them to find out, 2 years later that they are still in the same place simply because all the effort didn't move them, move them exactly in the opposite direction or in an unwanted direction. And if you look closer as to why, it's simply because they have no idea of what the territory is.
Right.
So, and when you don't know that, right? So that's the first order problem. Now, on top, as I said, I very much believe that this is just the very beginning of this conversation. This is not the end of it by far, but it's and I think it's such an important conversation to have, and it will have many implications. So, for example, there's another interesting topic on the same thing. So you have and Tony Fish, with whom I interact sometimes, he's talking about the hidden bias of like the decisions that the companies bury into their existing systems. Mm-hmm. So, for example, during COVID, right, it became immediately, so when this whole shift happened, it became immediately obvious that, well, we need to hire for new skills, for example, simple problem. So we need to build new kinds of systems. We need to hire new kinds of skills. But all your HR automation drives you to some other skill. Like it's highly optimized for you to hire some other kinds of. So like accelerating that one will just not get you to this outcome. And the interesting problem is that there is this hidden knowledge that is embedded in the existing system or systems that if you do not know, you're not in a position to influence your future. So that's basically, again, like comes back to this, it boils down to this again, like this idea that the first order problem is you need to know what today's computation is and does, and then only then afterwards to build on top of it. And that's basically the first hole that we're filling there. So that's the limitation. But perhaps I can give you maybe an example of how we are playing with this.
Yeah, let's look at that.
Let's see if we find one. So I have here one that I'm very fond of showing because it's an actual business problem we actually played with, and it's it's like a system. It's an restaurant automation in this case. So it's again, like I'm not going to describe everything, but this is a restaurant in a room and tables in a kitchen. And so it turns out that a lot of the problems in a restaurant are actually not so much they are not so much about inventory or so. but a lot of them is about how different actors communicate. So here we have a waiter and a cook, and they place an order, and then it goes there, and then at some point this one goes transformed, it goes to the cook. At some point the cook now has to wait and cook, and then at some point says, oh, somebody has to come and deliver it, and then it goes all the way to the waiter, and so it's now there. Okay, now what's interesting here is that this is something we drew on a whiteboard. So we have technical people, you have business people draw this on the whiteboard, and then we say, okay, let's go and implement this, right? So this is something before you have the system, but once you have the system, and basically you can start to have these kinds of things, like here's a cozy corner, a kitchen, a room, a table, and a waiter over here. So if you can see, okay, the kitchen is in the corner, the room is in the corner, table one is in the room, John Waiter is at table one and table two, and the cook is in the kitchen. So if I look at this representation of what I thought before, right, I can script it and I can imagine the previous picture. And I can imagine that one. But if I run this, I get an object, which is in this case is this cozy corner, and now all of a sudden it knows how to draw itself. So one of the things that I didn't show before was that, well, in order for this view over here, this red thing to transform into the blue thing, there is some computation that happened there. So and it was not represented here, but it needs to be represented here because otherwise it won't work. So if I now execute this and I endow these objects with now behavior. So in this case, there's like some little when something, do something else. But we don't have to go again into that. So I just simply endowed these little actors over here with some behavior. And now if I now I'm going to say, okay, let's place an order here. So what have I done here? This is a visualization of the restaurant, the static restaurant, right? And now I want to say, I want John Waiter to place an order at table one. And so if I execute that, I'm going to see this view.
Tudor, can I just, so I think
Sure.
this is fascinating, but take U venue as an object. What is it subclassing? What is U venue, for instance?
Right. So we go, I clicked on this one and I see venue, and I can see, okay, there's a meta view over here. So, and I can see that this is a subclass of area. So if I click on that one, which is a subclass of actor, so I can actually look here in the class hierarchy. That's pretty much what I have.
Okay.
So
the reason I was interested is I think what you're doing here is exactly the sort of thing I could imagine a group doing. I was in trying to think about what do our collective mental models look like.
Yeah.
I was just curious about the time cost of building the underlying objects.
So that's exactly the exciting conversation, right? So first of all, how was this created? So we actually create this. There's an algorithm that happens here. There's a way in which this message is propagated, and we can write some tests against this. Right? So you can say, let's decompose this, and we can write. And we did that exactly that. We wrote the test. It was all green, but we couldn't draw it.
Right.
We couldn't draw it. And what happens then? And we see this pattern over and over again. It's so easy. This decomposition over here is a functional decomposition of the problem. So basically, if I can think of it, I can think of it as a function that once the John Waiter places an order here, then Jeff Cook has an item on the to-do. That's pretty much the test. Because this order reaches Jeff Cook, and so a new item appears on the to-do list. So that's exactly how we drew it. And it worked. It worked perfectly fine, but we couldn't draw it. And because we couldn't draw it, right? And then we wanted to be able to come here and say, oh, actually, what happens when it comes here? But then you do it at this moment, just to have this little thing over there. All of a sudden, right? And the fact is, right now here, I'm inspecting the red message. So that means that the red message needs to know what's the blue message, and it needs to know what the cyan message is. It needs to know which objects, which nodes it basically reaches. So it turns out that we needed an immutable data structure there. It was not enough to just have a function that just goes over and visits all these nodes. we had to remember all of those. And then we had to remember and make the order, the message itself became a first-class entity because we now needed to go and inspect it and visualize this. So all of these things happen as a consequence of us wanting to visualize what the algorithm does inside. Why was this important? It was important because we wanted to show this new thing. And the new thing was, in order to have a model that works, usually models, you want to express them in both with at least by 2 dimensions. So conciseness is one of them, and expression or expressivity is another one. So how quickly can you make it? That's conciseness. And how expressivity will say, how many things can you make with it? So in this specific situation, for example, we say, well, let's adopt a new use case, like a completely different kind of use cases. And the use case, for example, here is when a guest comes in and joins this restaurant. And I open the phone, and how will this work? And so if you look into the space of restaurant automation, these 2 use cases, what the waiter does and what the user does, are considered to be completely different worlds, and that are not describable with the same metaphor or with the same thinking. So we said, well, we think that this can be, there is a way to describe this whole space in the same way. And so we wanted to be able to exercise this one. So right now, if Alice places an order, interestingly enough, the only thing I've done, I added a new node, but everything else behaves the same. So what I've done now here, I create, so this view that I have here became a little, a theory playground where I can play with the model to see and explore some an unexpected side of the space. And this is where it goes towards your idea of saying, can I expose my model? And then can I play with it in some ways that's maybe less expected? Now, here's the, so the difference between just a normal execution that looks like this and this little tool over here is measured in, it's maybe an hour or minutes, sometimes. And it was not so sophisticated at the very beginning. At the beginning, it was just like 10, 15 minutes. But there's such a dramatic improvement between this over the default way of how do I look at an object, right?
What really interests me about this is the potential multi-step process. So let me put this in concrete terms. Let's go back to the problem we were working on about opioid addiction in the US, and having 20 or 30 people come together to talk about it. Presumably, before one could build these sorts of diagrams that might, for instance, want to express how does someone first become addicted? Let's take that a step. We need to have the conversation about what are the objects in the system. And that is a fascinating first conversation. How would we model this? Because once we have a large vocabulary or large enough vocabulary of objects, then we could talk about how they interact.
Yes, exactly. And this, so here's where it gets really a little bit more crazy. This kind of pictures that you see here was actually what we used to talk with business, but it also was part of, pictures like that is what we make it part of pitches to investors. Now, what you think about it, what are these? This is an algorithm in this case, right? And this is an algorithm that no user will ever see. But making so we just took, this is like some detail in the very core of this system. And we can transform this, literally transform it, right? First of all, I could explain it to you in minutes. It turns out that you can make a business case out of this, just of these pictures. And you transform it into very high level, strategic level of decision making. But then at the end of the day, what I've just shown you is just a normal, some development environment with some object that I just took out of the system, and I made a story out of it. And what kind of story I can make out of it? Like this is the same view that I used to define to identify bugs, for example. Eventually, I did that. But then it turned out that you can use the same views to talk about investments. And that's like crazy. And what this only shows, and when we found ourselves in the first time we found ourselves in an investment room was, and we were just showing, here's some playground and here's an inspector and the thing here was, that was crazy, was that we were not thrown out of the window, out of the room after 3 minutes, right? We were there for like an hour. It doesn't matter what the outcome was at that time. The interesting thing was that there was a conversations to be had. And nobody today talks in any meaningful way about the black box of software, right? This is how far we can go. And this is just the beginning. The potential here is huge. And so you were talking about this, like just talking about the objects in the software world. People are talking about, the domain and how do you model the domain. So domain-driven design is now a term that people use, but very often that domain is shared, and then people talk about the ubiquitous language. So exactly that idea of sharing a language to describe the problem or the space between technical and non-technical people. So people with different perspectives, different backgrounds and different experiences. And so that they can actually identify a solution together. The problem is that language is pretty much captured on the whiteboard. Nobody knows whether the language is actually representative for the system. But what if we can take all of those whiteboards and project them everywhere in the system, such that any conversations, like I would like to see, and we want to see demos of systems showing here in the inspector. That's why we started from the inspector. We didn't start from, let's build some low code, I don't know what visualization that goes on the outside. There is visualization here. There is interesting, coding and analysis and so on. But at the end of the day, the most exciting part is, are we able to tell interesting, exciting stories for multiple stakeholders about the inside of computation? And the answer is, by now we know that this is possible. The amount of applications, I think, is broad.
So I want to build on this idea, and because what you're saying is really piquing my curiosity, around where you've got, for instance, Alice Guest. This model that you have made visible here is really interesting, because it is describing sort of the normative process. This is what we are saying is happening. And where I think this would be so interesting to extend is to sort of continue with the restaurant example. We might say in this model, Alice comes in and orders a hamburger, and we're saying that sort of normative description, this is what happens. But where you have people with multiple perspectives, we could use this to ask the question, say, Alice comes in, now what does she do? And people with one perspective might say, well, clearly, I have high confidence she is going to order something vegetarian. Someone else will say, no, she's clearly predominantly carnivorous. And you can then start to flow that out to be able to say, we are using this model to express the fact that we are seeing this problem differently. Now let's elaborate the Alice Guest Table 1 to John Waiter part with new objects or new values for properties, so that I could show you, this is my version of the model, this is your version. It has different outcomes, and we can actually start talking about not just she behaves in a different way, but this is why I think she behaves in a different way, because this is what I had to do to the model to get the outcome that I believe typically happens. That kind of elaboration around the model seems really interesting.
Yeah, I agree. That's so where, for example, you see also that one is in AI models, which are about describing how some describing some rules by what some sort of inputs in reality happen or will work. The issue again, like, and I think there's an interesting thing. We start to see more and more visualizations of the outcome of models, but still underneath, right? It's still based on these huge black boxes that we still don't have a grasp on, and
Right.
so that's why I think it's so important to start from the smallest and most basic types of issues, which is like this one. This one is not yet made, so was more targeted towards, okay, let's actually show that we can represent with the same model both a waiter and a guest use case, and then we can play with those, right? And then we could take here a career use case, like you order by phone and kind of things like that. So and that was the variation that we were focused on. But now, if we start to say, well, let's predict the behavior, for example, of the guest, or let's categorize the behavior of the guest. That's another problem that goes on top of it. And so, but if I have an understanding of this base layer, then I have a much more interesting basis to start understanding the higher order kind of questions that I might have. That's why it's so important to start from that every part of the conversation is answerable. That there is no black box in this whole thing, because any black box has the potential of you having to rely on a belief that is not real. And so, and as I said, like the potential to go upwards, I think is super fascinating. That's why I'm saying we're very at the very beginning here, and we are just showing that it is possible. And then that we are actually applying the same principles to work on or to basically deal with like with the platform itself, the platform that I was showing this. We're using the same process. There's nothing special here. It was absolutely the same process to build Glamorous Toolkit itself as it was to build this model. There's no difference there. That's the interesting thing of it, which means that it can potentially scale upwards in terms of the process, not in terms of the actual actions. But the way of thinking, we can just apply it over and over again because it seems to work. So that's why that's exciting.
And what I find so intriguing about this is being able to take this sort of object modeling perspective and then use it as a way of talking about different perspectives. So to take it back to something more concrete, so if we go back to this opioid addiction problem, there are, certainly in the US, a range of different mental models in play in terms of policymakers. I'll give, well, actually, sort of one really simple example. In some places, they have a quite widespread, what's known as harm reduction programs. So the underlying idea there is people are addicted, they will need to consume these drugs. We need to give them safe ways to do that as part of helping them no longer be addicted. In other states or in other places, they specifically say, no, we're not going to do anything that would make it easier or encourage people to take drugs. So you can see that there are two very different explanatory models in play there. If you look at it sort of at the top level, one is, yes, we'll have harm reduction. The other is, no, we won't. But underneath that, there are whole collections of assumptions that lead to that behavior. And so in the same way you were modeling sort of orders and waiters, we could take that approach to model people's thinking. And then the bit that we really want to get to, and this is why I think Glamorous could be a really fun tool to do this, is to be able to sort of start asking people, what is you've made an assertion here, in effect, this goes to that. What is your confidence of that assertion? And what's my confidence of that assertion, assuming I agree that such a thing happens? And now let's talk about why we might have very different levels of confidence around that. But until we can actually get people to draw models of how they think, in this case, opioid addiction as a system works, it's almost impossible to get them to actually talk about their levels of confidence in the underlying elements. And until we can do that, all it really is a, oh, yes, it does, oh, no, it doesn't conversation, which gets us nowhere. But if we could model confidence in the system and start getting people to talk about, why am I confident that this happens or not confident? So you could see whether it's higher levels or underlying levels. I'm not entirely sure yet, but that's why I could see it being so powerful.
Yeah, no, I definitely agree. Yeah.
Good. Well, we better go and get on with it then, hadn't we?
Okay, that's it. Good.
All right. So, and what is your advice as to how I might get started? Where do I start with Glamorous if I wanted to build something just a little bit like that? Where's my entry point?
Well, so I think so. There are a couple of use cases. The way we advise people to start working with Glamorous Toolkit is by taking a concrete scenario that they have an interest in, and then building on that one. So here in this space, we have a couple of different, let's say, use cases. One of them is maybe analyzing the system code, and another one would be exploring some APIs or maybe data. But you seem to be more interested in the modeling side of things. So projecting some model of reality or something, doesn't have to be reality, but some model onto some computation. And so this level of just identifying objects. So that's basically what I would start from. And one of the important parts there, if we go back to our example here, is that what I have here on the left-hand side, this is just it's essentially an example, right? So it's a scenario, very concrete, with very concrete steps, and then plus a set of views on the in this inspector, right? So I have an object as a result, and then I'm looking at it, and I have these views. So once I have something like this, I can also I can take those views and examples, and I start composing them into situations like this. So, right, this here's a document of the same thing, and this is a more elaborate one. And again, this is interactive and so on. So same kind of thing that I've saw before, but this is happening inside a document. Now, the question is, where does this thing come from? And this comes from something we call an example. So if I look at this example, that's the code that creates this. And this example over here is setting something up, right? And then it asserts whether or not it works. So up to now, it looks like a test.
Yeah.
The differentiator here is that this little test here actually returns an object. So you can think of it like examples are like tests that return objects. So you take exactly the same flow that you would take to do test-driven development or something of that nature. But instead of just getting this kind of void or methods that don't do anything, so that's what pretty much all testing frameworks today do. They stop at the assert. So a test pretty much is interesting as long as it's red. So people look at it as long as it's red, but as soon as it's green, boom, that's it, it's done. And then we thought, well, this is like a tremendous waste, because you went through all of this trouble to create this beautiful object, and then the best thing that people can think of is throw it away. So we said, well, okay, let's be a little bit more inclusive, and let's return this object. So now if I return the object, and because this is now a method that is an example is executable, I can actually execute that, right? And I'll get an object. But because I have these views, I can start interacting with it. Right? And I can have something like this. So now I have, not only do I have my object, but I actually have my normal test-driven development flow looks very much, there's no difference between that and prototyping in the playground, because they're not any different. They're exactly the same.
Right.
So, and if I can do this, then I can also then assemble them. I can also assemble afterwards narratives. And then you can turn the problem upside down, because you can start from the narrative. What is the narrative that I'm interested in actually constructing? And then I will be building my system so that I can support the narrative. And that's basically the driving force. So like, you should think about like what we started from. We said, okay, you have multiple people. They have to decide together, which means that they first, but in order for them to do that, they have to share a common understanding of the problem. And then you can also do it the other way around. We say, well, if I want to get you to think like me, I want to be describing what I think. And so that's a narrative. And I will be building my system such that it supports my narrative. And then I will be using that to talk with you. And then you will have a much more interesting chance to have a conversation with me. And this is where the communication compression happens. And then, of course, when you have an interest to talk with me, then you'll want to build your narrative. And then I will be looking at that one. And this is how we ping pong, basically. So the system becomes our common agreement as to what the model should be. That's what a system is. It is always like that, whether or not a system is always a negotiation. So as soon as you have two people working on building a system, that system is going to be a negotiation. So every single commit to code in code, right, is a tiny little move in that negotiation. And unfortunately today, most negotiation is implicit. And as a consequence, it's very easy to go into conflicts, and those conflicts only bubble up when it's too late. But if you turn this thing upside down and say, well, what if why are we not optimizing for the negotiation? Then all of a sudden the narratives become so important. And then it follows from there that you want an environment that is suitable for constructing these narratives. So what are the two pieces that you want to play with? Well, examples is one of them, and the views is the other one. That's pretty much it. That's what I would start from. Start from a problem and drive it through these kinds of examples. And then again, like these examples. So by the way, one interesting part here is that if I take this one, I can see that this is actually based on another example and on another one. And so because the examples return objects, it's very easy for me to construct in other examples. And so if I look at this, for example, example class over here, and I'm going to look at this map, I can see that there's not like a linear thing. There's a very deep possible implications of examples. And again, like an example, what is an example? It's my understanding. It's an explicit encoding of my assumptions. That's what assertions are. So that's another level of interestingness. So who's building, which assertions are based on my example? So let's say you have constructed this example over here based on my example from here. I can also turn it around and say, oh, that's an interesting thing that you thought that these two things are related in this way. I think they're related in the other way.
That's exactly what I'm after. I hadn't really thought about it in a sort of TDD or EDD perspective, but you're right. Assertions combined with confidence would be a really interesting way that you invite people to show you their models via an example which comprises both objects and assertions, but with levels of confidence. And that would be a fascinating starting place for a conversation.
Yeah.
All right, so I need a clean image. I go and is there actually, well, obviously there's an example set of classes because I can see you've got the pragmas in there. When it came to say modeling the kitchen, that you just created.
That's another system from somewhere else. But if you're looking for, so we're using these examples throughout the whole system. So the complete system is described. Like we don't have tests, we just have examples. As I said, like the whole system is built in like from the ground up in a different way. So following the methodology from that perspective. So let's say if I look at, this is just these are the tests for the graphical stack, right? Which is completely uninteresting for most people. But so in this case, for example, we wanted to test animation. So now animation is a first class entity. And then in this case, I have those things. But sometimes, I don't know, here I have some representation of the text. So when I look at this one, I actually see what. So here I took a hello. So if I execute this one, I get hello. And because I don't know what I've done, I just did from 1 to 5, then all of a sudden I get just hello. So, right. So again, like I just explained what the algorithm did just by looking at those, and I can represent it. So they're all of these, there are so many things that are just being described exactly in this way. So all of these we take exactly the same path for everything. So now let's say if I'm interested to get, so here, for example, I have the tree view of a rope. A rope is just a data structure. And I can see that basically this one is a method called and is annotated with GTView. So another way to start when you want to do this, when you want to play with Glamorous Toolkit, is to learn how to learn. Because Glamorous Toolkit is built in the same way throughout the whole system. So it's interesting to anything you learn about Glamorous Toolkit, you can use Glamorous Toolkit to learn about it. So let's say that I'm interested to find out all the views. So now what I will do now is I will open a playground over here and I'll say, I want this GT view that I just copied because I saw it there. And I'm going to say, I want all the pragmas. Pragmas is the name for annotations. So I want all the methods that are annotated like that. And so now when I look at things, I will see, okay, this is a method like this. So what I've just done here, I just use a query to find things about my own system. So once I have some question, I can transform it into a query, then afterwards will help me go and find the next one. So as I go forward to this, and I say, okay, look, for example, this one is a view with column list. I can just go and take this one and say and I'll say I want references for this. And when I execute that, I'll be getting views that are both annotated like that and like this.
Right.
So again, but the process, notice how the process is rather simplistic. Like it's pretty much always starts with the playground, whether it's about the domain that you're going to play with, or it's about asking a question about something in the system, it still starts in the same place. And that's an interesting, again, unification. And that's simply because any boundary in software is arbitrary, which means that there is a systematic way to go and translate any other question that I might have about the system. So that's pretty much how I'll go about this. So if you go on the first page of Glamorous Toolkit over here, you'll see a couple of starting slideshows. So querying fire code is one of those, which is what I would start looking at. This will teach you how to use queries, like the one I mentioned here, for example. Right, so here are those and those. that do that. So this is how we learn about our own system. This is just one mechanism. There are more of them, but we start with that. Inspect the views is another thing which is rather important and is not that difficult to to play with. So you can see here, interactive explanation as to how views affect the actual widgets, and yeah, it goes through those. It's again the whole thing is not that difficult, but once you learn how to learn, and you realize that the environment is there to help you learn, if you focus on that one, then the whole process becomes much simpler. So there are two ways to learn a tool. So most tools are just thought of as features, a set of features put together. We think of this environment as being the language. So a language which is made out of visual interactive operators. And the way you learn Glamorous Toolkit is by learning the language, not by learning a tool. Because if you count the amount of clicks that you can possibly do here, it's just a huge amount. But if you learn the language, all of a sudden it's much more manageable. So approach this one as a language and not so much as a tool.
No, makes perfect sense. And I think a language is in fact what we really need. It's a language for talking about questions and ideas and being able to visualize them. All right, Tudor, I am enthused. I am going to go off and play. I really appreciate you taking the time to sort of walk through this. And I think example-driven development as a way of getting people to externalize their mental models about how they are thinking about a question or a problem would be a really interesting approach. So I will go and try that. No doubt I will be back going, wait a minute, how does this bit work?
Absolutely. Thank you very much. Yeah, I'm very happy to have you on board. And let's continue the conversation. And we already, we have a welcoming chat on Discord for other people that want to learn about where that conversation happens. We also have a forum, but there's a lot of lively conversations happening on the chat. And you can find it on gtoolkit.com, the links. And we encourage everybody else to come and join this conversation. And thank you very much for your attention and interest. And let's continue the conversation.
Brilliant. Thanks a lot. Cheerio.